Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see in detail about the batting approach. Batting is one of the most commonly used technique by data scientists in order to improve the accuracy of the model. So today in this video, what we are going to see is what is batting approach, in what kind of scenarios we use batting approach, what are all the various steps that is involved in the batting approach, right? How do we build it? What are all the examples of batting approach, some of the insights of this particular approach, and finally, implementation using Python. So let's get into the presentation. Like first one, as you see on my screen, batting approach is also called as bootstrap aggregation. So why it is called as bootstrap aggregation? So we will go into the visual representation in order to explain this. So as you see this image, so this image is taken from Wikipedia. So as you see in this image, what happens is in any problem, we have a training data set. We have n number of observation as part of the training data set. So in batting approach, what we do is we create n number of samples. So how do we create the samples? We create the samples by using the method called as sampling with replacement. So when I say sampling with replacement, what it means is that the observation that is present in the first sample or the first group can reappear in any of the further samples or groups. When we use sampling without replacement, what it means is one observation can appear as part of one group only. If you have 100 observations and if you're going to create 10 different samples or 10 different groups with sampling without replacement technique, what would happen is there will be only 10 observation in each of those groups because one observation cannot repeat itself. So now coming to the point, it is called as bootstrap aggregation because creating n number of sample is called as bootstrapping. Like we try to come up with small building blocks and then try to solve the problem. So it's called as bootstrapping, creating n number of samples and then building a model on each of those samples in order to come up with the final prediction. So that's called bootstrapping. Aggregation because after creating n number of models, so then what we do is we take the output of all those models and then we aggregate it in order to come up with the final prediction, and hence it is called as aggregation. So batting approach is also called as bootstrap aggregation because of this. So when do we use batting approach? Like why should we use batting approach? If you have a problem where the variance is very high. So for example, if you have a data set and you have built a model which has a very good accuracy on the training data set, but when you use the same model in order to predict for a new data point, what happens is the prediction error is quite high, which means that the variance is quite high. What it means is that the data is trained on the training data set. So maybe there is some noise on the training data set which is being considered as a pattern by the model, and hence when you have a test data set, the same model is not performing up to the benchmark. So that's a scenario where the variance is quite high. So if you have any of this particular scenario, like in training data set the accuracy was quite good, but test data set the accuracy is quite bad. So in those cases, what is happening is there is a problem of overfit. So in order to solve the overfit problem, what we use is the batting approach. So how do we build the batting approach? So in terms of batting approach, what we do is, as you see in the picture, we have n number of records. So we divide those records into multiple groups. With sampling, by using the sampling with replacement technique, what happens is we can come up with n number of groups, because the observations can repeat itself. And then what we do is we create a model for each of those groups. So what we call this as a weak learner, because each of these models can be very simple enough. It can be slightly better than any random prediction. So when we have let's say n number of weak learners, n number of basic model which is just better than a random prediction. So when we take the average of all those, what happens is it becomes a strong learner. It becomes like a much better performing model. So that's what is going to happen in batting approach. So here, so the data set is divided into n different samples. For each of those samples, we build a model. So it's the same model that's been built across the n number of samples. So each of those models produce an output. The average of all those outputs are taken, and then the final prediction is being made. So that's what is called as batting approach. So this is the steps. So as I explained, what happens is the first one is break down the training data set into n different samples. So here the training data set is divided into n number of samples, like 1, 2, and this is the nth sample. So then what we do is we apply the model on each of those samples. And in order to make the final prediction, we take the average of all those. So if it is a regression problem, it is quite simple. We take the average of it. In case of classification, if we are using probability, we can still take the average. Whereas if we are not using the probability in classification, so then what we do is we go for the voting approach. What is the majority of the model saying? If the majority of the model is going with 1, let's say there are two groups, 0 and 1. If the majority of the models are saying 1, then we go with 1. If the majority of the models says 0, then we go with 0. So that's what is happening. So when we have a new data set, like when we want to make the prediction for the test data set, what happens is, so each of those test data set will go through all those models here, and then the output, the prediction from each of those models are taken. So in case of regression, as I explained, the average will be considered and the final prediction will be made. So that's what will happen in the batting approach. So here, what are all some of the insights? Like batting is one of the first ensemble model, the first successful ensemble model that was widely used. So here bootstrap is an resampling technique that produces, as I explained, bootstrap is an resampling technique which produces n different samples from the training data set. And the next one is the same model is used on all the samples. So as you see in this picture here, the same model is used on all these different samples, and the weightage for each of those models are consistent. In case of a batting approach, each of these models have same weight. So it doesn't matter whether this particular sample is producing a better accuracy or not, whether the last group or the last sample is giving us a better accuracy or not. It doesn't matter. What we do is we give equal weightage for all those models, and then we take the average of it. So that's the most important point in case of batting. So when we go to boosting, like it changes. So hence in batting, what happens is we create n samples and we build models for each of those samples, and we give equal weightage for all those models. The model aggregation, like finally after building multiple models and by aggregating all those models, what happens is we are reducing the overfit, we are reducing the variance that could come up in the final prediction. If we are using just one model, there is very high probability that there could be an overfit, and hence the variance could be high in the test data set. But by taking the average of all those models, what we are ensuring is we are ensuring that variance is reduced. So this technique can be applied to any algorithm. So you can use like decision tree, you can use SVM, or you can use any algorithm, and this approach can be incorporated to that particular scenario. So it doesn't require you to use a specific algorithm, like whatever could be the algorithm, you can incorporate a batting approach in your problem, like in your solution. And finally, one of the best advantages of the batting approach is it can be parallelized. How it can be parallelized? Each of these samples, the models that we are going to build on each of those samples is independent of each other. So the performance of the model on this particular sample that you see here doesn't affect like how the model or how the model should be for this particular sample. Each of those are independent. So hence what you can do is you can, if you have the computation capability, you can ensure that all the trees are built simultaneously, and hence it will be extremely fast. So these are all the various advantages or like the insights about the batting approach. So now having seen enough about what is batting approach, right, how it is being built, and say various insights about it, so now what we will do is we will go to a simple Python implementation and how to incorporate batting approach. As you see, first one is we need to import all the required package. So here, maybe before importing, I'm going to clear the output. So now the output has been cleared. So now the first step is to import all the required packages. So these are all some of the packages that we are going to use. So this exercise, this code that you see here is the same one that we used for that we used to explain the SVM algorithm. So it's the same one we have used. I have used the same script. What I'm going to do is I'm going to incorporate the batting approach in that particular scenario, in that particular algorithm. So then we are going to use the same data set that we used for SVM. So this is the data set. So we are going to use the same data set, and we are going to drop all those NAs as you see here. The NAs are dropped, and then we are going to divide the dependent as well as the independent variables using this. After dividing the dependent and independent variables, what we do is we split them into training and testing. So in general, the test data set can be 20% and the training data set can be 80%, but the training data set can be anywhere between 70 to 80%. So depending upon your requirement, you can change the ratio as required. So now we are going to split it into training as well as test data set. So now comes the batting approach. So this is the details of batting approach that you can see in the package explanation later, and then these are all the various parameters that can be used. So the base estimator is what kind of algorithm should be used. So it can be custom algorithm, like if you are going to use SVM, you can pass on the SVM model here. If you don't pass any estimator, by default it will take up as decision tree, and then it will try to build the batting approach. The N estimator is the number of base estimators that should be present in the ensemble model, like how much samples the data set needs to be divided into, how many models you need to create, how many models you need to run simultaneously. And then this is the match samples, the number of samples to be drawn from X to train each of those base estimator. What should be the maximum number of samples? What should be the maximum number of features? If you have X number of n number of features, how many features needs to be used? So if you don't provide the match features, by default all those features will be considered. And bootstrapping, how do we use bootstrapping, with replacement or without replacement? If false, sampling without replacement is performed, and then these are all the other features. So now coming to the batting approach. So in order to perform the batting approach, what we need a batting classifier. So it is part of the ensemble stlearn ensemble package. So we import a batting classifier. So now what we do is we are already using the SVM technique. So this is the SVM algorithm that is being used in order to build the model. So now what we do is we pass on the SVM algorithm as the base estimator, and what we are saying is the N estimator is 150. So 150 is quite low. So in general, when you want to build quite a complex model, what you try to do is maybe you try to build at least 500 models in parallel, and then you try to take the average of it. So here, because of the computation time, what I'm doing is I'm settling for 150 as the N estimator, and then random state as 42. Then we use fit in order to train the model on the training data set. So once the training is done, so let me execute this. So this will take few seconds, because we are going to build multiple models in parallel, and then we are going to take the average of it. So let's give few more seconds for this to complete. So now this is complete. So now next one is we are using .predict in order to make the final prediction. So now when we use .predict, what happens is, so this test data set will be used across each of those models. So in this case, we have N estimator as 150. So this data set will be used by all those 150 models. The predictions would be made, and then finally we aggregate the results in order to make the final prediction. So now the final prediction is stored here in this particular variable, and then we are going to use confusion metrics in order to see the performance of the model. So this is the performance of the model after using the batting approach. So as you see here, I haven't done any transformations. I haven't done any modifications to the dataset. I haven't in fact done any kind of analysis to the dataset. So by simply using the data as it is without doing any transformation, without analyzing it, without maybe removing some of the features that are not going to help in the prediction, by using it as it is, right, after removing all those NA records. So this is the accuracy of the model. So if you want to improve the accuracy of model, what you can do is you can do some exploratory data analysis to see what are all the various features that are important, what are all the features that are not important, what are all some of the transformations that can help in improving the accuracy. So this is the approach. So it's quite simple, as you see here. The sklearn package empowers you with all those functionalities, so which makes implementation of Badin very simple. So all you need to do is you need to import, you need to import a Badin classifier, and then you need to pass on the base estimator. By default, it will be decision tree, but you can use any algorithm here. And then you need to specify the n estimators. So this is one of the mandatory requirements. You need to specify the number of models that needs to be built. And finally, we use fit for training it, and then we use .predict in order to make the final prediction. So that is it about the Badin approach. So I hope you have learned something new today. If you have learned something new today, please give a thumbs up and subscribe to my channel. If you are aware of someone who is trying to learn data science, please share this series with them so they're able to learn data science. Usually people who are trying to learn data science struggle because there is no structured way to go ahead with it. There are various topics like statistics, exploratory data analysis, visualization, like Pandas, NumPy, and so many other things, and hence it's very easy to get lost. So in this series, what I'm trying to do is I'm trying to provide a structure to your learning journey, and hence you would be able to learn all the important concepts that is required for a data scientist. So that is it for now. See you in the next session. Bye until then.